Algebra 2, this is 7.4, inverses. Inverses, for us right now, is mostly linear equations, and it's really easy to find and to do or deal with. The first thing I want to talk about when we talk about inverse functions, though, is the fact that inverses are doing the opposite, right? So if I took 5 steps forward, the inverse would be 5 steps backwards. So when we talk about functions, we talk about the idea that a function is going to start with x and it ends with a y. Its inverse will take that y, that output, as the new input, and its output will put you back where you started. That's what an inverse would be. So, the very first thing I want to talk about is the fact that what if I was just given a chart with 2, 3, 4, and then put 5, 6, and 7. If this was a function given to you as a table, what would its inverse table look like? What would the inverse of this table look like? Basically, every input is now the output, and the output is now the input. Follow? You picking up what I'm putting down on that? Basically, it says I'm going to switch x and y. So now it's 5, 2, 6, 3, 7, 4. Why? It's because in the first function, if I put in a 2, I'll get a 5, yes? Its inverse has to start with a 5. Chug and plug it, you get a 2. It puts me back where I started. I started at 2, I went someplace, did the inverse, came right back. That's an inverse. So the first thing that they want you to recognize is that inverse tables are just switched. So if it asks you to find the inverse and gives you a table, just switch the x and y's. That's number one. Okay? The second thing that it wants you to do is it actually create or find the inverse to an equation. There are 2 steps. So finding inverse. 2 steps. Number 1, switch x and y. Number 2, solve for y. Boom. That's the only things you need to do. You switch x and y, solve for y, and you're done. So, let's do this. Y equals 2x minus 3. This is your function now. Find its inverse. To find its inverse, step number 1 says switch x and y. So what is it going to look like?
X equals 2y minus 3.
Yeah, x equals 2y minus 3. At this point, I will solve for the y. The y now is inside. To get y by itself, I first get rid of the negative 3 by adding 3 to both sides. So I got x plus 3 equals 2y, and the last step is to? Divide by 2. And so you get y equals, you guys remember how to split that up? I don't like to leave it as x plus 3 over 2.
Usually we just left it.
I want to split this up, because this is a line. Most of us wouldn't recognize that's a line equation. So I'm going to split them up to their own denominator. So that's x over 2 plus 3 over 2.
Oh gosh.
You need to split it up. Because that means the slope's 1/2, starting point, or your y-intercept's at 3/2, or 1.5. You guys could graph these. It's pretty cool.
Don't make us.
Now, before I move on from this slide, this is the inverse function of our original.
Don't you have to switch back?
We're not going to switch back. Because if you did switch back, you would get the original problem. But how do we denote which one's the original function and which one's the inverse function? We talk about inverse function notation. They sometimes will use a little -1 on the y.
Yeah.
Or, if we're using function notation, it's a little -1 on the f. That's y inverse or f of x inverse.
So what do you want us to write?
matters whichever one you want to use. I probably will default to this one because our problems will start off with y equals. If it starts off with f of x, use the f inverse one.
But you only use the f inverse once you get your answer?
Right, you'll use one or the other down here.
And that just
So
depends
this
on what-
down here should be y to the little negative 1. That would denote that you said that's the inverse.
So it just depends on what the equation is. when
Right.
they give it to us.
Right. It matters how they give you the problem is how you're going to
Is that-
leave it.
Are these,
The second to last thing is what happens if it's not a linear equation. Now 90% of the time you're going to be dealing with linear equations because that's what we know how to graph really easily and we're good and familiar with. But sometimes they're not. Sometimes they have exponents that are higher than 1. Well, remember, f of x is the same thing as what? F of x is
why?
y. So I would just change it to y. But guess what? After that, follow the same rules. Switch x and y, solve for y. That's it. Those same two things apply for all functions. And so, add 2. Switch x and y first. X equals 1/2 y cubed minus 2. Now get y by itself, so it means you need to move the 2.
Wait, let us do it.
Okay. Times it by 2, because we need to get the y cubed by itself, yes. So, I'm going to change colors to make this a little easier. I'm going to multiply the whole side by 2, right? You guys recognize that? Because these 2 and 1/2 are inverse multiplication inverses, reciprocals of each other. And at this point, I'm going to distribute. So 2x plus 4 is equal to y cubed. To get rid of a cube, take the cubed root of both sides. So guess what? We now just found y inverse, right? Technically, because we got y by itself. And it's the cubed root of 2x plus 4. Done. So to properly name this, we would say f inverse of x, because we started off with function notation of f of x. The last thing that I'm going to ask you to do is verify that these are inverses. And to verify if they're inverses means they are inverses. We're not asking are they. It's saying they are inverses, show me they are. But wait a minute. I said that an inverse does what to a problem?
Opposite.
It's opposite, or puts it back where it started, right? So this is the thing. What number am I starting with? I don't have a number. I have a variable. What variable do I start with? X. Guess what I need to get out? X. Now, this is what's going to happen. You need to use composition. You need to show that, okay, I'm going to change up something here quick. I had a change here. One of them we're calling f of x and the other one we're calling g of x. We already determined that these are inverses because we found them. Let's verify it though. So to verify that they're inverses of each other, I have to use composition. I have to show that f of x, or f of g of x is equal to x. And, big and there, g of f of x also equals x. That means if I place one inside the other, I get x out. And it has to go both ways. You have to be able to switch g inside of f and f inside of g. If one does not work, they're not inverses, you're done. If it works in one, you got to test the other. So, let's do this. F of x, which is our first function on the outside here, is 2 times something minus 3. What's going inside it? It's g of x, right? Because it's g of x inside here. G of x is this. X over 2 plus 3 over 2. That should reduce down to x. Well, what am I going to do with the 2? I'm going to multiply or distribute in. Guess what's the denominator on all of those?
2.
2. What's going to happen with the 2's? They're going to cancel. That's going to cancel and cancel. So you get x plus 3 minus 3. And those will cancel and you're left with x.
Equals 0.
No, equals x.
Equals -3.
No, the 3 and the negative 3
Plus
cancel.
3 minus 3.
Oh, yeah.
Just gives you x, right?
Yeah.
Okay, so that worked. We're happy. We now have to go to the other side and say, okay, I'm going to start with something divided by 2 and add 3/2 to it. What am I putting in this one? 2x minus 3.
Hey.
So, okay, now, guys, this part right here goes back to what we did earlier, that I have a common denominator. I can split this up. That's 2x over 2 minus 3 over 2 plus the 3 over 2 from here, right? See how I split this one up? Well, the 3 over 2's will do what? Cancel. 2x divided by 2, the 2's cancel, and you're left with x. Therefore, 3 dots means therefore, they are inverses. We just verified. They both gave us x out. Good to go. That's how you prove or show things are inverses.